Okay, this is lesson 1 of unit 5. I'm going to start talking about triangles and polygons. So this is triangle fundamentals and some of the interior angles. Okay, here's some definitions and such for a triangle. The definition is it's a closed figure that's formed by the joining of 3 non-collinear points with 3 line segments. Okay, this is a picture of one labeled ABC, and this is what it looks like. Okay, naming convention, the triangle with vertices A, B, and C is simply named triangle ABC. Alright, the components of triangle ABC are the vertices, which are the 3 points, the sides, which are the 3 line segments, and the angles, which are the 3 angles, angle A, angle B, and angle C. Okay, that's what makes a triangle. Triangle classification according to angle size. And this is a way that you do this. You've done some of this before. An acute triangle is a triangle in which the measures of each angle is less than 90 degrees. Okay, an obtuse triangle is a triangle in which the measure of one angle is greater than 90 degrees. And a right triangle is a triangle in which the measure of one angle is exactly 90 degrees. Okay? That's the 3 types of triangles that you have. Oh, and they also threw in this one, an equal angular triangle is a triangle in which the measures of all 3 angles are equal. Okay? Alright, if you classify triangles by size or by the lengths of sides, first one you have is a scalene triangle, which simply tells you that all 3 sides are different length. And they're drawing your attention to the tick marks. 1 for this one, 2 for this one, 3 for this one. That means that each one is a different length. Okay? Then you have an isosceles triangle, a triangle in which 2 sides have equal lengths. Notice the tick marks. Okay? These 2 are the same. This one is different. Then you have a theorem here. It says the base angles of an isosceles triangle are congruent. So the base angles are always these that are directly across from the 2 sides. Okay? That are congruent. So in this case, that's what we have. Okay? And then we have an equilateral triangle. It's a triangle in which all 3 sides are the same length. Notice each one of these has a single mark on it for the tick mark. That means that all 3 sides are congruent. Okay, example 1. Write the word acute, obtuse, right, or equiangular under each triangle so as to identify that type of triangle. Okay, so this triangle right here, we have what? Since it's got 40 and 30, and this big angle is 110, that makes it an obtuse triangle. Okay, this one over here, all 3 angles are less than 90 degrees, so that makes that an acute triangle. Okay, this one down here, 30, 60, 90, that means that this is a right triangle. And the last one over here, all 3 angles are 60, so that makes it an equiangular triangle. Okay, example 2, they want you to write the word scalene, isosceles, or equilateral under each triangle so as to identify which kind it is. So this time we have this one. We've got 3 different markings on it, so this makes this a scalene triangle. This triangle over here, these 2 sides are marked with a single mark each, so that means that you have 2 sides that are the same length, so that makes this an isosceles triangle. This one over here, all 3 sides are marked with a double tick mark, so that means this is an equilateral triangle. And the last one here has all 3 sides with different markings, so this is a scalene triangle. Okay. All right. Notice in example 1 that all the triangles, all three angles always add up to 180 degrees. Okay, this is a true thing for the kind of triangles we're going to be talking about. The sum of the interior angles of a triangle is 180 degrees. This is arguably the second most important theorem in geometry. The Pythagorean theorem is considered the most important one. Okay, begin with triangle ABC, having angle 1, angle 2, and angle 3 is shown. Draw a line parallel to side AB, thus forming angle 4 and angle 5. Okay, so what they're going to show you here is this. Angle 1 and angle 4 have to be the same because these are alternate interior angles between these two parallel lines. Angle 2 and angle 5 have to be the same because these are alternate interior angles with the parallel lines. So the three angles of the triangle, 1, 2, and 3, add up to 180, which makes the straight line. Okay? And that's what this basically says. Okay? Example 3, if two angles of a triangle have measures of 28 and 113 degrees, what is the measure of the third angle? So since they all have to add up to 180, we simply say 28 plus 113 plus x equals 180. Subtract the 28 and the 113 from 180 gives us 39 degrees. Okay? The exterior angle of a triangle is formed by extending by one side of a triangle and the extension of another side. Interior angles are inside the triangle. Okay? So the extension to this line formed with this side, that is our exterior angle. Okay? So they want us to find the measure of angle 2 in this diagram. Angle 2 is an exterior angle. Okay? Here's what the thing is. We know 78 plus 35 plus 1 equals 180. Okay? So this way we can actually figure out what angle 1 is, that is 67 degrees. Angle 1 and angle 2 are a linear pair. So this means that the two of these have to add up to 180. So the measure of angle 2 plus the measure of angle 1 equals 180. Measure of angle 2 plus 67 that we know is 1 is equal to 180. So that gives us that measure of angle 2 is 113 degrees. Okay, notice that the 78 and the 35, these two angles right here added together also come up to 113. So one of the theorems that we have is that the exterior angle is always equal to the two angles inside the triangle that it does not touch. So that's what it's saying here. It's always the measure of an exterior angle of a triangle is equal to the sum of the two remote angles. The two remote ones are the two that it does not touch. Okay, example 5, they want you to find the value of x. The three angles of a triangle always add up to 180, so x plus x plus x equals 180. So that gives us 3x equals 180. Divide both sides by 3 gives us that x is equal to 60 degrees. Okay? From the results of this, we can conclude that the measure of each angle of an equiangular triangle is 60 degrees. Something else they're not telling you right here is that if it's an equilateral triangle, it also has to be an equiangular triangle. So if you see an equilateral triangle, you immediately know that the angles are 60 degrees. Okay, find the sum of x plus y. Okay, so since this is a right triangle, that means x plus y plus 90 equals 180. Subtract the 90 from both sides, gives us x plus y equals 180 minus 90. And so it tells us that x plus y equals 90 degrees. Okay, so from those results we can conclude this, that the two acute angles of a right triangle are complementary. In other words, these two angles in any right triangle will always add up to 90 degrees. Okay, that finishes this lesson. Thank you very much. If you've got questions, be sure you bring them tomorrow. Put them on the parking lot. I will have 3 questions for you to answer as well. Thank you very much. Goodbye.